Hello student, we'll see whenever a four-wheeler or a car or jeep or truck is moving on a level circular road, we'll observe the frictional force acting between tire and the road provides the necessary centripetal force on the vehicle. Now, if the vehicle is moving at a certain speed which is not giving skidding or skidding is not there, then we'll equate the maximum frictional force acting between tires and road should be equal to the centripetal force. So we can find out the speed which can be provided by the friction force acting between tires and road. So let us see one by one. On level circular road, what should be the maximum speed of the vehicle and why banking is done. Now to reduce the friction, we are going to bank the road, and there the friction force is reduced on the banking, because on the banking the component of normal reaction acts towards the center of the circular road and it provides the necessary centripetal force there. So by banking we reduces the friction. Now then we'll see also if friction is also acting on the banked road, then we'll be getting two situations. One situation when the speed of the object is very high or maximum speed. What should be maximum speed, that also we'll see, and at minimum speed the vehicle will be moving on the circular road but it will have tendency to come down, so that also we'll see. And then we'll see on level circular road if the skidding and overtopping, suppose the object is moving with a very high speed, then we'll observe sometimes the four-wheeler or the jeep or truck overturns there. Now what is the reason for overturning? Sometimes skidding takes place and sometimes overturning takes place. So in what situation the object will or the vehicle will overturn, that also we'll see. So first we'll see, first one is, suppose on the level circular road, suppose on the level circular road, Now when a level circular road is taken, means both inner and outer edge of the road is at one level. Suppose this is the center of the road, center of the circular track, and this is road, and on this an object is moving up. Object is moving here. Now we'll observe here this object is moving with, let us take v speed. Now here you will observe the frictional force acting between tires and the road. The frictional force Fs max that is acting there, and this will provide the necessary centripetal force towards the center, Fc. And I can write down the maximum value of this limiting friction or static friction acting between the tire is mu(s) time normal reaction, right? So this can be written as mu(s) time mg or mass of the vehicle, and this will be equal to mv square by r. So I can find out the maximum speed v max on the level road can be given as mu(s) time gr. Is it? Now you will observe the speed, maximum speed is function of mu(s) and radius. Right, more is the radius of circular track, more is the speed, and more is the coefficient of friction between tire and the road. The maximum speed will be more there. Now, suppose a heavy truck is moving on this one. Now, when a heavy loaded truck will be moving, then you will observe the mass of the vehicle will be very large, and in that situation, the frictional force which is generated between tire and road is very high, and there is chance that due to this high friction, high amount of heat will be generated between tire and the road, and the tire may get punctured. Now in those situations, when a very heavy or heavily loaded or loaded truck is moving on the circular track, then we generally bank the road. Or with the banking, let us see what happens in case of second example. We'll see banking of the road, right? banking of road. Why we do banking? First, it should be clear why banking is done. Now, I will write down if a heavy vehicle is moving, then what will happen? Then the Fs max, the maximum friction force, which is mu(s) time normalization, or mg, that is very large, and due to very large friction large heat will develop, and the tire of the vehicle may damaged, and that is why in that situation we bank the road. Now in banking, what we done actually, the inner edge is kept at lower level and outer edge of the road is kept at higher level. Now let us take this height of the banking, and let us take, this is base B and this is the road. Let us take, this is L. Now on this the vehicle is moving, right? Let us take, this is L, and on this the vehicle is moving. So what happens? It is moving on the circular track. Now you will observe in this situation, if theta is banking, I can say here the normal reaction is now tilted. This N is now tilted, right? Weight is acting in this direction, mg, is it? Now this is the direction of centripetal acceleration towards the center of the object, towards center of the circular track, and we'll observe here, this is theta, so this is theta, so you will observe this angle will be 90 minus theta. I can say this angle will be theta, right? This angle will be theta. If you observe, this is theta, 90 minus theta, 90 minus theta, so this is theta. Now I get two components of N. One component will be towards the center, that can be written as N sin theta, and another component is vertical, N cos theta. Is it clear? Now I can write down N sin theta. N sin theta provides the necessary centripetal force, mv square Vr, and N cos theta balance the weight, right? So I can say the angle of banking tan theta can be written as V square by Gr, or the maximum speed V max can be written as root under Gr tan theta. So if angle theta, value of tan theta increases from 0 to 90 at infinity, so radius is more, tan theta is more, maximum speed will be more. Now suppose I say at this speed, when the object is moving with speed root under Gr tan theta, we'll observe no frictional force is acting between tire and the road. So I can say if speed of the object is root under Gr tan theta, what happens? No frictional force act between the tire and road. Now if speed is increased from this value Gr tan theta, root under Gr tan theta, if speed is increased, then what will happen? The frictional force, now the vehicle will have tendency to skid outward, and the friction force in that case acting towards the acting on the tire and the road towards the inner point of the road. So their friction force also comes into picture. So let us see if friction also act on the banked road, then what should be maximum speed of the vehicle and what should be minimum speed of the vehicle. That also we can see. Now I can see from this diagram, let us draw if friction is acting. Third situation is if friction friction acts on banked road, on banked road, then what happens? Now let us see the diagram first, the free body diagram of the vehicle, and then we'll solve the what is the maximum speed. Now this is theta. Let us take, this is the vehicle, this is representing the vehicle of the object on the banked road, right? These two backside tire, wheel of the vehicle, and this is direction for the, I can say, normal reaction, and we have seen in this direction the weight of the object acts mg, right? Mg acts, this is theta, so you will observe in this direction this is theta, so I can say, right, now this angle is also theta, this is 90 minus theta, so I can say this is theta. So in this direction you will observe the component of weight is mg cos theta, and in this direction you will observe the weight component is mg sin theta, mg sin theta. Now frictional force, if the speed is very large, in that case it will have tendency to go outwards on the banked road. So in that situation the frictional force acting will be towards the center. This will be direction of frictional force. I can write Fs max, and in that case we'll see this will be the direction of centrifugal force acting on the object, that can be written as mv max square by r, if r is the radius of the circle. This I can write. Now you can see this is theta, so obviously this will be 90 minus theta. I can find two values for this. mv square, one value will be towards this direction. This will be mv square r cos 90, that is sin theta. So I can write mv max square by r sin theta is acting normal to the surface, normal perpendicular to the inclined plane, and another component will be acting in this direction, and in this direction I can say the force mv max square in this direction I can mv sin 90 minus here, that can be written as cos theta. Simply add cos theta here. Right, now we know the maximum value of frictional force, Fs max is nothing but mu s time normal reaction, and normal reaction will be sum of these two. I can say mu s time normal reaction is this much, mg cos theta plus m v max square sin theta divided by r. Is it clear? This part is clear. Maximum value of frictional force. Now this will be acting in this direction, and mv square cos theta. Now in case of limiting stage, I can say Fs max plus mg sin theta will be balancing this one. So I can write down m v, if I take parallel to the inclined plane, f v max square by r cos theta will be equal to the downward force parallel to the incline is Fs max plus mg sin theta. I can write mu s time mg cos theta plus mv max square r sin theta. This is mu s time n plus mg sin theta. Is it clear? This is the value. Now I can take mu s time mv max is on this side, so I can write gets cancelled, all m gets cancelled, so I can write down v max square r, in bracket I can take cos theta minus, if you take on this side, mu s time sin theta, and on right hand side I can take this value as g common, right, and then I can write down mu s cos theta plus sin theta, right. So say from with this one, the maximum speed Vmax can be written as root under gr, and this will be sine theta plus mu s cos theta divided by cos theta minus mu s sine theta. Right. Now divide by cos theta. If you divide by cos theta, we want this will tan theta. So I can write the value as gr tan theta plus mu s divided by 1 minus mu s tan theta. This is the value. Now if we replace by angle of friction, if I say mu s is tan phi, where phi stands for angle of friction, then I can write the maximum speed. Maximum speed can be given at root under gr tan theta plus phi, where phi is angle of friction. Where phi is angle of friction. Now in case of minimum speed, the vehicle will have tendency to come down, and in that case frictional force will act in upward direction. So in case of V minimum, just change the sign of friction. I can write down gr tan theta minus phi. Is it clear? Where mu s is tan phi and phi is angle of friction. Is it clear? So on the banked road, if friction comes into picture, we'll get two limiting speed. One is maximum, another is minimum. In case of maximum speed, the object will have tendency to skid outward, and then the maximum speed can be written as gr tan theta plus phi, and minimum can be written as gr tan theta minus phi. Now this is on banked road when friction comes into picture. Now let us see how the overturning of the vehicle takes place. In case of overturning, what happens? How the overturning of the four-wheeler takes place on the circular road. Now if we consider the overturning moments, now let us find out the overturning, how it takes place, overturning. Right, so that is called overturning. And when skidding takes place, when overturning takes place, both will see overturning and skidding of the four-wheeler on circular road. Now fourth will take overturning of vehicle on let us take level circular road. Level circular road. Now let us take the vehicle on a level circular road. Now we will observe here. Let us take this represents the vehicle and the center of gravity. This represents the ground, and let us take the center of circular track is somewhere here. This way, vehicle is moving on the circular track, the center is on the right hand side. Now let us take the R1 is the normal reaction, and here R2 is on the outer wheel, right? And let us take, this is center of gravity of the vehicle, CG, and you will observe this, let us say this represent mg, and this is A, and let us take height from the ground is h. The center of gravity is at h height. Now in case of, you will observe the friction will be acting towards the center, F1 and F2, right, between the two tires, that will be acting towards the center. Let us take V, the speed. So I can say the centrifugal force here will be nothing but mv square by r. Now I can find out in case of our moment about the outer wheel at this point. Now R1 plus mv square by r into h will be equal to mg clockwise. So let us find out sum of moments about outer wheel. I can say R1 into 2a anti-clockwise, R1 into 2a is anti-clockwise, mv square by r into h anti-clockwise, that should be balanced by clockwise movement mg into a. So I can say R1 is nothing but R1 can be written as mg, 2R1 can be written as mg, a gets cancelled here, and then minus, I can say mv square by radius into h by a. This I can write. Is it clear? Now I can find out 2R2. The reaction on the outer wheel is sum of these two, mg plus mv square by r into h by a. Now here you will observe the reaction R1 is less than R2. Now in case of high speed, the overturn takes place in towards the outer, the vehicle starts rotating about the outer wheel and R1 becomes 0. So in case of overturning, I can find out R1, the reaction on the inner wheel is 0. The reaction at inner wheel is 0, and from this expression I can say mg is equal to mv square h by a r, or I can say v can be written as g r a divided by h. So this is the overturning. So I can say the overturning speed is g r a by h. Now when it was when the friction force is acting towards center, now when it starts skidding, in that case friction force will be equal to only mv square by r. So the skidding velocity or the skidding speed is nothing but it is mu s gr. Already we have found on level circular track, mu s time normal reaction, mu s time mg will equate mv square by r. So I can write this. Now these are the two speeds, one is overturning and one is skidding. Now on the same if actual velocity or the actual speed of the object, let us say, or if I say the overturning speed is greater than the skidding, then what will happen? First overturning, if speed goes on increasing on the circular track, then skidding will take place first. Then skidding takes place first. And if skidding speed is more than overturning, then overturning takes place first, right? So it depends which is more. If overturning speed is more, then first skidding will take place on the circular track, and if skidding speed is more, then overturning. If you go on increasing the speed of the object, then without skidding, the vehicle will overturn. So that depends on the overturning speed depends on radius, the wheel, base width of the wheel, A, and then H, height of the center of gravity of the vehicle, and the skidding speed depends on radius and the coefficient of friction between the tire and the road. So this is all about how the skidding and overturning takes place on the circular track. Now, if I take one example, let us take mu s is 0.1. Let us say mu s is 0.1. R is 100 meter. Let us take, and then I can find out. Let us take A is 2 meter. A is let us take 1 meter, and H is, let us take from the ground. It is around 1 meter. Let us take this value. Now we'll observe the skidding speed is how much. If you place the value mu s gr, the mu s into g is 10. So this will be 100. So this is 10 meter per second. And overturning speed you will observe if you place in this value 10 into 100 into 1 by 1. So 10. This will be 10 root 10. Now what you observe here, the skidding speed is less and the overturning speed is more. So if we go on, if the vehicle is moving with 9 meters per second, nothing will happen. At 10 meters per second, you will observe skidding will start. And if you go on increasing, if it is 11 meters per second, the vehicle will start skidding towards outer edge of the road. So skidding will take place the moment the actual speed is more than 10 meters per second. Now, if I say mu s is, let us take another example, mu s is 1.0. In that case, you will observe this will be also 10 root 10 skidding. Overturning will be also 10 root 2. So in this situation, what will happen? Now both will take simultaneously. Skidding and overturning will take simultaneously if higher coefficient of friction is there. And if mu s is more than, if I say mu s is, let us take more than 1, then you will observe skidding will be more than overturning. So first overturning will take place and then skidding. And the overturn, there is no question of skidding. So this is all about the circular motion, four-wheeler vehicle moving on the circular track. So these are the different values. So if you like the video, please subscribe.